Hello, my name is Scott Grizzard. This is the quiz review for Quiz 2B for spring 2021 from the University of South Florida. Let's just jump in. A little late today, so we're getting everything together. Okay. All right. So let's go ahead and get started. Quiz keys. Quiz. Okay. So the first question asked you to state two cops and a drunk. I put up the left version. You could have done the left version. You could have done the right version. You could have done the two-sided version. All good. Okay. This is in Blackboard Collaborate Ultra. So the statement, let f, top, and bot be functions. This is all preamble. A, some number in the x space. L in the y space. If for all x left near a, top is bigger than f of x, bigger than bot of x, and the limit as x goes to a from the left to top of x equals the limit as x goes to a from the left of bot of x equals L, then the limit as x goes to a left of f of x equals L. There's the little picture. The way that the scoring would work here. So 1 to 5, how do we feel about this one? This is question 1. Oh, perfect. So question 1, Laura's on top of it. 1 to 5, how do we feel about this? Now, please ask any of your questions that you have in text chat, either on Twitch or in Blackboard Collaborate Ultra. The drawing is worth 2 points of refund. This, of course, being the preamble, is worth 1 point of refund. If you do a drawing and nothing else, you only get 2 points. However, if you do the drawing and then do it here now, and then wrote this bit out here, you would get full credit. And then 2 points if you miss something here. Now, the way that I remember this theorem, I don't remember this, the words. Here's what I remember. I remember that there's a top function, there's a bot function. There's some function that's drunk, it's in the middle, hence 2 cops, top, bot, and a drunk, F. Right? Everyone, as all of these functions head to A, as top and bot head to A, they're nice and cleanly, in the Y space they go to L. Right? So as x goes to A for top and bot, y goes to L. F is trapped between them at some point and stays there. So left near, I've got this. Okay? So 1 to 5, how do we feel about the picture? What I memorize is the picture. I don't memorize the theorem. I memorize that there are two conditions and one conclusion, and then I memorize that there's this picture. That's what I do. Okay? How exact does your definition need to be? Your statement of your theorem needs to have these elements. It needs an if statement. It needs if, 2 things, then 1 thing. It needs to have this idea that x near a. You could have done the left-handed version or the right-handed version or the two-handed version. But you need these 2 conditions, and you need it to be usable. And that's what I'm going to be talking about tonight when lecture. So lecture 2B, which is tonight, Wednesday's lecture, we'll be talking about what do I mean by making these useful. Okay? And you'll see why it's important. When you're writing proofs, you'll see why you want it in this form. Okay? Now, an intuitive answer is going to get some points. Not full credit. An intuitive answer plus a picture plus a preamble would get close to full credit, but not quite there. Right? You really need you really need these kinds of statements in order to use these theorems. And that's one of the nice things about this if-then structure with these bullets. It means that you can crank it out. Now, why do I want you to memorize these? It's not like in a bar 10 years from now, that some person of your preferred gender is going to come up to you and go, hey, I'll sleep with you right now if you could tell me what the squeeze theorem was, word for word. No, never going to happen. As much as I'd like it to happen, it's never going to happen, right? You're never going to be in a bar and a person of your preferred gender offer you, a romantic interlude if you have this memorized. But you may have a job which has technical definitions. Okay? And so there's a skill here. There's a skill about memorizing a technical definition. The skill is this. skill. Understand, draw picture, memorize picture, reconstruct from picture. And that's a skill. And that's an important skill, because that skill is actually useful to you in the future. I don't actually care 10 years from now if you know two cops and a drunk. I do care whether or not you can understand a technical definition in whatever your field is. Okay? Draw a picture and interpret that definition, memorize the picture, and then be able to reconstruct the definition. That's an important skill. So think of it less as this thing is pointless and think of it more as doing reps, right? We're doing exercises. By memorizing these definitions and reproducing them, we're doing exercises and making our brain used to being able to do this. 1 to 5, how do we feel about the why? Why we care about this? Right? We care about this skill. We're exercising our brain in a new way to memorize the definition. And here's how you do it. You understand what the definition's saying. You draw yourself a picture. You remember the picture, and then you reconstruct it from the picture. Okay? Can I read the points intuitively? I think what you're asking me to do is you're asking me to say what these things are from the intuition. The intuition is that if I'm left near A and top is bigger than F is bigger than bot, if top is on top and bottom is on the bottom, and F is stuck in the middle, and if everybody's heading toward, as X goes to A, everybody heads to L, or top and bot head to L, then F gets squeezed in between the two cops, corner, and moved in there. It's stuck between them. Those are the points into infinity, intuitively. Now, here's what the book had to say about it. You could use the book version for this. As I said, the only thing that I was really pissy about the book is the way they define a function, which is not actually what a function is. A function is not a rule. It's just a set. But that's the only one I get pissy about. All right? They've got this nice drawing here that's very good. There's a link here. I'll post the key. I haven't posted any of the keys. I will. But this is the link to the thing in the book. They're nice little doohickey, but you can find this in the book. Okay. All right. Let's state some limits. Okay, now, this right here, this is f of x equals 1 over x. This function is very, very important. 1 to 5, how do we feel about the idea that this function, f of x equals 1 over x, is very, very important? We care about this function. It's going to be with us the whole time. All right? Now, if you don't have the picture of, if I say 1 over x, and this picture does not go poof in your brain, what I want you to do is I want you to go on Desmos, I want you to graph this function, and I want you to print this function. I want you to print 3 copies, maybe even 4. I want you to take 1 copy, and I want you to go to your bedroom. I want you to go to the ceiling of your bedroom, and I want you to stick it up on your ceiling. Okay? I want you to stick it up on your ceiling so that every night before you go to bed, you're looking at this function. Every time you have a romantic interlude on that bed, when you're in certain positions, you're looking at this function. I want you to take another copy of this function. I want you to go to your bathroom. I want you to stick it on the wall up opposite your toilet. Every time you're on the throne, I want you looking at this function. Every time you're on the throne, you should be seeing this function. Okay? Forget your Economist magazine and your Psychology Today. I want you looking at 1 over x. I want you to print one up on waterproof paper. I want you to stick it in your shower. Normally, you'd be singing a little Barry Manilow. You'd be doing a little, let's see, Frank Sinatra in the bathroom, And I did it my way. I want you to instead and start singing to yourself. You're going to look in the shower. You're going to see this function. When I head to 0, 1 over x goes to infinity. If I'm going from the right, if I'm going from the left, it goes to negative infinity. And that's how I do it my way. You know, I want you to see this function. You should have dreams about this function. 1 over 5. How do we feel about the importance of this function? Okay. Have I stressed to you how much you need to have this function in your library? Okay, so as I go to infinity, 1 over x goes to 0. Okay? As I go to 0 from the right, 1 over x, y goes to infinity. As I go to 0 from the left, y goes to negative infinity. As I go to negative infinity, as x goes to negative infinity, y goes to 0. Okay? I'm going to do the limits of tan and sine in a second. 1 to 5. How do we feel about these limits of 1 over x? Now, as 1 over x, as x goes to 0, from the left it goes to negative infinity, from the right it goes to positive infinity. Therefore, as I head to 0, the limit doesn't exist, right? Negative infinity does not equal positive infinity today. Okay? All right, guys, you need to vote. Your vote matters. Vote. I want to know how you feel about these things. I really want to know. I actually care about your opinion. There's only 50 people in the class right now. Your vote is 1/50th. Your vote matters. Your vote in the presidential election doesn't matter. Well, if you believe Trump, it really didn't matter. If you believed Biden, then it mattered a little because your vote was the count was honest. And I'm not saying what I believe. I believe the reasonable position, whichever one you think that is. But I'm saying that your vote matters. All right? There you go. I love that. Someone said Kanye. All right. So let's go over these others. Oops. I'm way out here. All right, sine, the limit as x goes to infinity as sine of x does not exist. So the idea was that every sequence in x that goes to infinity, that sequence in y would need to go to some number. Okay? So here's what happens. I could pick this sequence right. I could pick pi over 2, 5 pi over 2, 9 pi over 2, and so on and so forth, going up by 4 pi over 2 or 2 pi every time. And I could wind up with a sequence that is y equals 1, y1 equals 1, y2 equals 1, y3 equals 1, y4 equals 1, and blah, 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 blah. I go off there, and I'm always stuck at 1. So this red dot would represent the sequence 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And the limit of that sequence is 1. However, I could choose -1, I could choose a sequence 3 pi over 2 and then add 2 pi every time, starting from here, and wind up with the sequence -1, -1, -1, -1, -1, -1, -1, -1. So as I go to infinity, this does not settle. 1 to 5, how do we feel about that? As I go to infinity, this does not settle. The quiz keys will be posted. I just haven't posted them yet for this class. Okay. Now, that's not to say that it doesn't settle sometimes. Okay? If I'm not going to infinity, let's say I'm going to 0. If this function is going to 0, it settles. But if I go to positive infinity, it doesn't settle. There's a difference there. All right, guys, vote. Come on, vote. 1 to 5, how do we feel about this? Vote. I've got, I need at least 50% turnout here to get a good idea of what you guys are doing. How you guys feel about this. Okay. Someone's got their hand raised. Person with their hand raised, please type your question. 5 is good, yes. Okay. All right. Tangent. There's 3 ways. Okay. You got negative infinity for f. Yeah, so let me talk about f real fast. All right, let's talk about this one. Here's the function here's tangent. As I go to pi over 2 from the left, I get positive infinity. As I come from the right, I get negative infinity. Okay. Now, there's a couple of ways to think about that. The first way is to graph it. The second way is to think about what tangent actually is. Remember that tangent is actually the length. So if this right here is, oops, let's make this the, okay. So if this right here is the arc length here, tangent is actually the length of the line that skirts this, that's perpendicular to the radius at my point, right? Here's theta. Right here. Tangent is actually the length of the line that is tangent to the circle from its point of intersection with the radius, or the circle, back down to the x-axis. So as I go, it's not what I want the ruler. So here, if my angle is right here, I don't have much there, right? That's a very short, that's a very short, if my arc length is right there, I have a very short tangent. But as I move here, notice that as I move here, these lines get more and more parallel. And when I hit here, when I go, you see how long this line is now? How long the line from theta down to the x-axis is? As I keep going, I'm going to wind up with a line that's parallel to the x-axis. So that's why the tangent becomes infinity. Okay. The other way I could think of it is to think of tangent as sine over cosine. So as x goes to pi over 2 from the left, sine goes to 1, and cosine, right? Here's where I am. Here's my unit circle. Cosine is my eastiness. So cosine heads to 0 plus. Okay? So what I've got is 1 over 0 plus. That's infinity. 1 to 5. How do we feel about that? There are 3 ways to think about tangent. The graph, as sine over cosine, and to actually think about what that line is. Vote. The question was, how do we feel about the tangent? Or yes, you can use a calculator and keep throwing in numbers that approach pi over 2. But really, the best thing to do is to have one of these conceptions in your brain. Okay. So tangent, we're talking about the tangent line. And the length of the tangent line, the tangent function, measures the length of the tangent line from theta to the x-axis. That's what tangent actually is. That's its definition. This idea of sine over cosine, that's a theorem. And don't ask me to prove it, because I can't do it off the top of my head. I don't remember that much of my geometry. I don't remember the proof of that thing off the top of my head. Not to say I couldn't do it, but you'd have to give me an hour to refigure it out. Okay. For this one, as x goes to negative infinity, y goes to 0. How do we feel, 1 to 5, how do we feel about part A on my pretty graph? Okay. As x goes to negative infinity, y is heading to 0. Now, as I go to negative 2, f is the function on the pretty graph. Oh, what is f? I'll get to f in a moment. If you're asking about part F. I'm not sure which one you're asking me about. Okay. As I'm heading to negative 2 in the x space, I head to 2 in the y space. Okay? Whereas if I head to 0 in the x space, I go to 6 in the y space. 1 to 5, how do we feel about those two? This would be parts B and C. Okay. Now, let's look at some of these others. Let's look at all the ones involving 3. All right. So, as I approach, what is f of 3? F of 3 is 2. That's where the closed circle is. But the limit as x goes to 3 from the left is 4. And as I approach 3 from the right, f is heading to 2. Okay, so the limit from the left does not equal the limit from the right, and the limit as x approaches 3 of f of x does not exist. 1 to 5, how do we feel about those items there? That would be D, E, F, and G together. Okay. And note that f settles at 3, y actually settles at 3 at 2 as I approach 3 from the right. Okay? I can't have things at finite numbers that don't settle. Okay? So let's look at one of those. Okay, so here's two functions, sine of 1 over x and sine of x. Now, sine of x is the one that's in red, and sine of 1 over x is in blue. Now, as I head toward 0, notice how sine of x settles as I head to 0. In fact, if you zoom in far enough, it looks like a line. And that's in essence what the derivative is. You zoom in on any graph, on a function is differentiable if you zoom in close enough, you get a line. Or a line-ish. It looks like a line when that's like an intuitive definition of the derivative. The slope of the line that if you zoom in close enough, you get. But look what happens to 1 over x. There's no amount of zooming in that makes it settle as I head towards 0, right? As I head to 0, this thing keeps going brrrr, and there's just no, it never settles. Right? I keep zooming in and I never get something. As I approach 0, it just never settles. Whereas 1 over x, as I go to sine of 1 over x, as I go to infinity, that will actually settle. Settles at 0. Right? If I go zoom out enough, this thing right here is heading to 0 as I go to infinity. Now compare that to sine of x. This never settles as I go to infinity, right? As I go to infinity, this thing is still going. So 1 to 5, how do we feel about this idea of settling? So that's why h does not exist. It never settles. Okay, any other questions about the quiz? Harmonics, totally different things. Okay, so I'm going to stop streaming here on Twitch.